When researchers collect data on a sample of their population, they will often then generalize the results to the entire population or target group. These inferential statistics generalize results and make predictions about a larger population. You use inferential statistics when your analysis needs to go beyond percentages or averages of a single variable, and you want to understand the relationships between variables. Common inferential statistics include correlation, regression, t-test, and analysis of variance, or ANOVA. Correlation describes the relationship between two variables. When two variables are correlated, it means as one variable goes up, the values on the other variable will increase or decrease in a similar pattern. This similar pattern between the two variables could indicate a connection between the two variables. However, two variables being correlated does not indicate that one causes the other variable to change. There could be another unknown factor that influences both variables. For example, taller people tend to have a higher weight. Height and weight are correlated with each other. However, this doesn't necessarily mean that one variable causes the other, e.g., gaining weight doesn't cause people to grow taller. Regression shows the relationship between two or more variables. When you read an article that mentions regression analysis, the researchers were using this analysis approach to explain a phenomenon that they want to understand. Why did substance use rates increase during the last year? Predict something. Do restorative justice approaches reduce school dropout rates? Or make a determination as to the best option. Is this intervention most effective or a different one? A t-test makes a comparison between two groups, for example, an experimental group and a control group. Researchers use t-tests to compare the means of two groups and to test for statistical significance. For example, a study might use a t-test to determine if there is a difference in appointment no-shows between a group of clients who received a reminder call and those who did not. Analysis of variance, or ANOVA, can be used to analyze variance to compare differences between more than two groups. For example, with analysis of variance, you can measure the difference in weight loss between a group who received a nutrition program, a group who received an exercise program, and a group who received a combination of the nutrition and exercise programs. Correlation, regression, t-test, and analysis of variance, or ANOVA, are all ways to analyze quantitative data.